Welcome back to che205. In this video, I'll be talking about matrix determinants and few other operations for matrices using the Excel package that I explained how to install in the last video. So if you haven't watched a video before this, I really encourage you to go back and watch that and see how you can install the package. So the matrix package. Alright, so most likely you've seen how to calculate the determinant of a matrix in high school, but if you haven't, let's start with a two-dimensional matrix. Assuming that I have a matrix with 2 columns and 2 rows, so 2 by 2 matrix, I want to calculate the so-called determinant of this matrix. So by definition, determinant of a 2 by 2 matrix is the multiplication of the diagonal elements, a11 times a22, and then minus a12 times a21, the off diagonals. Okay, so the diagonals multiplication minus the off diagonals multiplication. We can actually do this in Excel now. You have to also install the package before calculating this. So let me show you how you can do this in Excel. Right, in Excel, the way we calculate the determinant of a matrix, let me just open up an example here. So it could be example 3.3. Okay, so I need to move this up. Alright, so this is my spreadsheet. Let me make it a bit shorter. Alright, and let's calculate the determinant of a 2 by 2 matrix. I'm going to create a matrix here. Let me just go to a new sheet. Increase the font to 14. Okay, so let's say I have a matrix 1, 2, 3, and 4. Okay, I want to calculate its determinant. So what I do is the following. First, you see that I don't have the package button that used to be here. So I need to activate that the matrix operation, or basically reinstall the package. Installation is not really difficult, it's very just easy. So the way you do it in Mac, again, you go to Tools, Add-ins, and then you select, and you refer to the unzipped file that I posted on Blackboard. Alright, so mine is located, let me see, here. Okay, and after you do that, then this matrix button shows up here. So I'm going to click on that, and I get this extra menu that I'm going to move and put it up here. Then I go to macros, matrix operations. Okay, so I want to do determinant, right? So I'm going to calculate determinant. So here's the option for determinant. I'm going to click on that. That's determinant. Then in this blank space here, it says matrix / vector A. So I'm going to click on that, and then go back to my spreadsheet and highlight the matrix. So I highlighted my 2 by 2, which exactly indicated, this indicates the location of the matrix I just highlighted. Okay, it's sheet 2, yes, that is sheet 2, and then element starting from A1, that's the upper left corner, that's A1, up to B2, and B2 is the lower right corner, so that's the box of matrix. Alright, and then, so that is the input. And the output, let's say I want to get the result, let's say here. Okay, so I go to this output blank area right here, and then click on the cell that I want to get the result. Okay, so again, let me just delete that. So I'm going to click here, then go back to my spreadsheet and click on a cell at which I want to get the results. Okay, so let's say I'm going to click maybe here. Okay, now if I click run, Excel will calculate the determinant of this and then put the result on this cell, which is D1. Okay, let's give it a try. So we're going to click run. And that's the result, it's -2. Let's make sure that is correct. So 1 times 4, right? So the determinant is the diagonal multiplication minus off-diagonal multiplication. So 1 times 4 minus 6, it's -2. That is correct. Okay? So I showed you how you can calculate the determinant using the matrix package. You can do 3 by 3, you can do 4 by 4. As long as the matrix is square, you can use the package. Alright. The next topic we're going to talk about is matrix inverse. By definition, matrix inverse is a matrix such that when you multiply that inverse by the original matrix, you get the identity matrix. So let's say our original matrix is A. Note that to get the inverse of a matrix, the matrix has to be square. We cannot calculate, and I don't think that exists, the determinant of a rectangular matrix. Okay, so make sure your matrix is square. Now, given that, by definition, inverse multiplied the original matrix would be identical to matrix, the original matrix, multiply by the inverse. So basically you can just swap the two and you still get identity. Okay? And if you recall, the identity matrix is a matrix whose diagonals are 1 and off diagonals are 0. Alright, let's use the matrix package to calculate the inverse of a matrix. Let's say I want to calculate the inverse of this 2 by 2 matrix. Okay, this is square. I go to this window again, and then in this menu I have an option here called inverse A, right? I click on that. Again, I highlight my matrix in this box, which I already did, right? So that's the box I want to calculate the inverse. And then the result will go to a different cell. Let's say I'm going to see my result here. So I'm going to click on that and then pick this up. You see that cell A4 is the cell at which I want to get the results. Okay, and then I'm going to hit run. So here it is. That's the inverse of the matrix. So the inverse of a 2 by 2 is a 2 by 2 matrix. The dimension of the inverse is exactly the same as the dimension of the original matrix. That's different from determinant. Remember, this is determinant. Determinant is a scalar. No matter what the dimension of the matrix is, the determinant is always a number. It's just one number. But the inverse of a matrix is a matrix, and that's what it is. So let's check to see whether this is really an inverse. To check, we have to multiply the inverse by the original matrix and show that that's identity. So I'm going to multiply the original matrix, which is this matrix right here, multiplied by the inverse, and I should get the identity. So I'm going to go and click on multiplication option here. And then now I have another position to input the elements of matrix B. So we're going to multiply A by B, right? Okay, so my A matrix is the original matrix right here. It's A1 to B2. It's right here. My B matrix now is going to be the inverse. I'm going to highlight my inverse matrix here. That goes to this area. It's A4 to B5. That's right. That's A4 is the upper left corner and B5 is the lower right corner. All right. And the result is going to, let's say this cell. Okay. Right. I think I'm set. I'm going to go and run it. And there you go. So that's the result. So I multiplied A by A inverse, and I proved that is identity. You see, the diagonal is 1 and the off diagonal is 0. So this actually indicates that we calculate the inverse properly. Second of all, you get to know how you use the matrix operation package to calculate the determinant, the inverse, and multiplication. You can also find the transpose, right? Let's say you want to calculate the transpose of the original matrix. I'm going to click on transpose. My original matrix is still the same thing, and I'm going to get the result somewhere else. Let's say I'm going to get the result here. Now I'm going to go and run it, and there you go. So this thing is the transpose of the original matrix. Let's double check. By definition, transpose is you're going to read the rows and write it as columns. So let's read the first row. It's 1 and 2, and in the transpose will show up as 1 and 2 in the column. The next row is 3 and 4, which show up as the second column, so 3 and 4, and that is a transpose. So now you know how to calculate the transpose using the matrix package. All right. The next topic is some definitions about some particular matrices. Okay, the first matrix I want to look at is symmetric matrix. Symmetric matrix is a matrix whose transpose is equal to the original matrix. Okay, like in this case, this matrix is not symmetric because the transpose of it, which is this one, is not identical to the original. Right? This is 1, 2, now this one is 1, 3. You see that's different. So let me make a symmetric matrix. So here, I'll just close this. Let's say I have a matrix 1, 3, 3, and 4. This is symmetric because the off-diagonal elements, which is 3 and 3, they are identical. I can even do a symmetric 3 by 3. So let me show you how to do that. So this one is a symmetric 3 by 3 matrix. First of all, it's 3 by 3, 3 rows, 3 columns. Second of all the elements around the diagonal or off diagonal elements are symmetric. So this is the diagonal. Let me color it. Off diagonal, you see that 3 and 3, they're the same. 2 and 2, they're the same. And 5 and 5 are the same. So another check is you get the transpose of this, and this should be identical to the original matrix. Let's calculate the transpose of it. So I'm going to go to matrix operation window and then click on transpose. My original matrix is this 2 by 3. And then the result will go to this cell and then run. So let's check. Is this matrix identical to the original? The first row is 1, 3, 2. Here the first row is 1, 3, 2. Second row 3, 4, 5, 3, 4, 5. And then the last row is 2, 5, 6. Here the last row is 2, 5, 6. So these two matrices are identical, given that the second one is a transpose of the first. So by definition, if the transpose is the same as the original matrix, the matrix is called symmetric. Otherwise, it's not symmetric. Okay, so I hope this is useful. Thanks all for watching. Stay tuned for the next video on calculating the linear system using the matrix package, which is section 3.7.